Hi guys. So the transistors have turned up for the 600 watt ATX power supply. I ordered a pack of 5. I only need 2, but it's always worth getting a few spares. You know, if you've seen something fail once, the chances are you'll see it'll fail again. Not, I said, on the same item, but you may see another one. So yeah, there they are. So here we have in bits the power supplies. You left it last time, a bag with the screws in and the various bits and bobs of it. So we're going to have to put this back together. First thing we can start off with is this is the PFC, power factor correction board. So we removed this heatsink because we had some strange readings, and it turned out that the fault was a short circuit on the other one, on this one. These transistors. I'll link to the other video, so if you like, yeah, watch that one. If you haven't seen it, watch that one first, then come back and watch this one. Huh. Something stuck on there. That's an EEPROM off the laptop screen that we couldn't fix. Yeah, I'm sure that's what that is. How it ended up here. Must have ended up on the desk and then stuck itself to this. That's another good reason why you should tidy yourself up. Yeah, tidy up after yourself. Okay, so that's put the heatsink back on here. Let's zoom down a bit and get soldering. Yeah, so this shouldn't be too difficult. I'll switch the soldering iron on, and I'll just get some water to put on the sponge while the iron's warming up. Being a T12, it won't take very long. So soldering iron's ready to go, and there it's bleeped, it's ready to go. Okay, so we'll just use a normal leaded solder, the 0.7mm, is it or stuff? Yeah, 0.7mm stuff, and we need to just solder these back in place. Now I recall now when we took this apart, we had a part of the circuit board here. Yeah, this lifted up. You see this little tab here, but it's still in place, so we can get some solder on that and make sure that it doesn't short across here. Yeah. So let's get soldering this first, I think. So I'll go for both the end devices. There should be some flux on this already from when I did the desoldering work. It looks like there's flux on here. Okay, so nice and easy to do this. Yeah, there's obviously flux on there. There's smoke coming from it. And that's got some solder on that centre pad. So that now shouldn't be able to move anymore. Yeah. Yeah, that's rigid now, so that can't go anywhere. And we can be sure that there's no solder bridges in here. Yeah. Just make certain we've got no solder bridges between the pads, because if you have, you'll regret it. You'll regret it if you've got a solder bridge in there. You'll be regretting it pretty soon. We can always double check this. It's worth, even when it looks okay. Stupid camera flashing one moment. Stop it. Okay. I don't know why that does that. You just put your hand in front of it or something and it stops, yeah. Let's get the meter where you can see it. Let's find something to stand that up on. There you go. Okay, so just testing the meter probes there, yeah. So we just check, make sure that we don't have any solder bridges here or here, yeah. I mean, it's not possible to get one across the two. Well, this is if you go across all three, yeah. So that's in. Heatsink sitting quite flat on there. So yeah, we have a peg over here that holds the heatsink to the board basically, so let's get on that one. It's nice soldered joint now. Let's go for the other ones. and then there's 3 over here. Yeah, that looks alright. Same thing, let's just be sure that we don't have any inadvertent solder bridges in between these. So again, we can just check. I think the outer 2 pins of this are actually connected. Yeah, you can see they're connected on the board there. This should read open, or the other way it'll read like a diode. It's a diode. I think it was a diode. Oh, that's the end. Actually, of course, it won't read like a diode because I'm on resistance mode. Now we're on diode mode. Yeah, reads like a diode. You can see 395, like a Schottky diode. That, yeah. Okay, that's good. And we just check on the other big transistor that we've just soldered to make sure we don't have any solder bridges here. Yeah, just see the diode junction. That's fine. Just see the diode junction. That's fine. Should see the same on this one. Yeah, diode junction. Diode junction. So that's fine. They're all done. Notice that the black wire has fell off while we've been waggling this around, and it's quite clear that it comes from here. Yeah, it's come out of there. So we need to just fix this back on. Otherwise, nothing's going to happen when we power it up. Okay, so we'll solder that. So we need to just clean the hole out. Let's get a bit of flux on this. I don't think I need the vacuum desoldering tool for this. I think I can actually do this quite cleanly. Okay. Little leaded solder again. I've managed to push the thing into the hole itself. So I'll get a pair of tweezers or something on the end of it. Should be able to pull this out. Yep, there we go. That's the thing. Get that out of the way. Might be hot at the moment, so here we go. So we now have a nice clean hole, and we can put the black wire back on. Yeah, might be an idea just to get a bit of solder on the end of this. Make it easier to go through the hole. So I don't want to make sure I don't have any like stragglers. Yeah, little straggly bits of wire on the other side where they could cause a short. That wouldn't be a good idea. Okay. Through the hole. And we can solder that one. It's a nice big hole, yeah. Nice big hole. Makes it easy to get that in there. Yeah. Yep, it's in. It's nicely done, so there's no chance of shorting out. Yeah. Okay. So that's that done. Now onto the other heatsink. So this is where we had the short circuit transistors. Yeah. Let's just move that out of the way a little bit. So these are the 2 transistors that were short circuit, 2SC3320, and you can see that that's completely short. Yeah. But this one read okay. Diode junction. Yeah. Diode junction, yeah. And collector emitters. Okay, so these two are the faulty ones. So we need to take these off. Okay, let's get these off here. Okay, that's that one. It's actually stuck itself down. It's well stuck. They've actually stuck themselves to the. It's like a effectively like an insulating pad that also is like a heatsink type compound as well. Yeah, so they've managed to glue themselves on. There we go. And the same with this one. That's just effectively. This one's really stuck. Ah. Yeah, it's off now, but that stuck itself very well. So the little rubbery pad is come off attached to the transistor, yeah, so that needs to go back in place. Again, make sure you put these things back because you'll definitely regret that if you don't. Yeah. That's our two faulty transistors, so the 2SC3320, yeah. Oh yeah, there you are, see. Here we go. 2SC3320s, yeah. So these are the replacements that arrived. Yeah. Just torch onto the right there. They look they look like the original ones. Same sort of markings on them. So yeah, let's test them. Always worth testing them first. I'll just try it first with the multimeter. Yeah. So this is base at this end. Diode junction. And they read like well, I can't say they read like this because they're short, but they look good. One diode junction higher than the other, yeah. Base collector, base emitter, yeah. Okay, there. We can also check these on the semiconductor analyzer as well. I'll just get that. We'll have to zoom out a little bit. Okay, so this is the semiconductor analyzer. So I've had this actually longer than I thought. I think I would have bought this back 2014, so I've had it for about 7 years. Cost me about £60 at the time, but if you watch the other video I did on transistors, you'll see that I've spotted devices that do what this does and more than this does on AliExpress for about €5. Yeah, €6. So I've ordered one. I actually, after that video I said I was going to, I've actually ordered one. It's on its way, and I'm going to do a video when they turn up to see, because if you can get something like this for like, you know, less than $10, it says germanium but it's not, it'll be silicon. Yeah, I expect to see a low gain. No, I've seen these say power transistors as germanium before. Germanium is an old type of transistor that has a lower forward voltage drop. Let me just try it again. Oh no, it's a triac. Let's just make sure that these leads clicked on properly. This is giving some very strange readings off these, but it looks okay on the test meter. On the multimeter, just turn the torch off. Let's try another one. So I have seen this do this before on occasion. Seems to get confused with some power transistors. NPN silicon transistor. That I'm happier with. Gain 11. No leakage. NPN silicon transistor. Let's go the same on the other one. It shouldn't matter which way round you put these legs, but let's just put the same as that one and see what it says. Blue, green, red. Let's get another one. I've got 5 of these. That's the same as well. I'm a bit surprised it's saying that actually, but I'll say the same as the first one. Let's have a look at the other two. That says that. I'm going to use 2 that say the same. Yeah, if that other one says silicon, I'm going to use 2 of the other ones. They ain't germanium transistors, I know that for sure. Ah, interesting. So that was an NPN silicon transistor. Gain 11. Forward volt base emitter 0.56. Yeah, and no leakage. So 11 gain, 0.56. Yeah. What's the other one that says silicon say? Gain 11, 0.56. Oh, I've got 2 that I'm going to use. I'm interested now. I'm interested now to see how these read, yeah? Gain 9, 0.54. Seems to be. Try another one. It's like recognising when the base emitter drop is less than a certain amount. It's saying germanium, because germanium would be about 0.2, a real germanium transistor. Gain 14, 0.54. Okay, interesting, but not that relevant. Okay, so now we've had some fun with that. Let's put the 2 on that said they were silicon. Yeah. Obviously, the original's been blown up dead short between all the legs. I can't actually compare with one of them. Yeah, I haven't got another one, another good one, to make a comparison. So let's try these. I might have a bit of fun positioning these right with the screw tight so the legs actually go through the holes, yeah? Let's see. See if I get it right first time. Because I'll check, but it might be difficult to tighten these screws once this is actually in place, yeah? So I may have to do it first like I've just done. I cleaned the holes out last time. It goes this way round into here, yeah? And we've got to see if we can insert it. I need to bend these. I need to bend these back a little bit. I can see that. That seems like it's bent, moving forwards a little bit. Bend them back a little bit. Let's see if we'll go now. Just remembered, I unsoldered this one as well. If I actually, because this one's in place, I might decide to solder this one first before it falls off, basically. Yeah. No, that's not in place. Okay, we'll that's not in place. We'll do that last. Yeah, I've forgotten I'd unsoldered that. So this is just a bit fiddly. That's all it is. It's just a bit fiddly to line this up. That's in now. It's in. A bit fiddly, but it didn't beat us, did it? It tried, but it didn't beat us. 1, 2, 3, there through. 1, 2, 3, there through. Huh. And the small one isn't in place. The legs have not gone through on this one. The other two are in, but this one here have not. So we can assume that that one is bent, or it's just not far, or because the legs of these are obviously long, it's not just not quite far enough down. Yeah, it's just not quite far enough in place. Trying to look down the gap now to see if I can get it in. Nope. This is not one that's going to be easy, is it? Let's have a look. I can see now that it's not actually lined up. I can see, you probably can't see, but I can see down here. I can see the holes, yeah, and the legs are not quite in line with the holes. It needs to go a little bit further forwards, or the legs need to be bent a little bit further forwards. I'm going to have to take this out. These need to be bent a little bit more forwards like that. Yeah, let's try again. See if it will go now. Right, those are in place. Now I've got them too far forwards. Let's see if I can get this down here, yeah, and just line these up with it in position. Let's have a look. I can see. You can't see. I'm sorry, my head keeps getting in the way. Try it from underneath. So I'm going to effectively shine a light upwards at it. Yeah, that's it. Now I can see. I can see clearly now where these legs should go. Yeah, into these holes. At least that's the theory. Just going to put the air conditioning on as well. It's getting warm in here. It's a bit better. Cool the place down. So yeah, it's in. It's in. It was just a matter of bending the legs on this to the right position. You couldn't really do it without pulling it back off, and you know. So having a look to see which way they wanted moving, and just trying again. Yeah. So this is in place now. So this peg here and this peg here are actually on the heat sink, so they hold it in place. So let's get them soldered first. Okay. You've got to be patient with these sort of jobs, guys. You know, you need a bit of patience for this sort of work. It's not something you can rush. If you're getting frustrated with something, put it down. Yeah, just put it down and walk away from it. You know, yeah, leave it a bit. Come back when you refresh your head. Yeah, there's no point getting frustrated with the job because it's not gonna help. But you know, we're all human, so sometimes we do get disillusioned or frustrated with things. Yeah, walk away from it. Come back later. and you'll probably find it's all, much easier. I soldered it, didn't want to solder that one. Soldered. Not soldered. Okay, so we have them all soldered in, so we'll cut off the legs. Yeah. Okay. And again, let's just do the same thing. Let's just double check our handiwork there. Yeah, see if we can get this meter a little bit higher up. Put something underneath it. So let's try that. No, no, too much glare on it. Too much glare. Yeah, I think you can see it now. Worse. Let me fix that off camera. Yeah, I'm thinking of getting myself a bench power supply, something that lights up. Yeah, I can use the little Unity one, but the display, like the little plastic cover, it's a bit scratched and scuffed. Because that gets taken out on site a lot, so when it's in your bag, it's going to get a bit worn. Yeah. So yeah, so these are the ones that we just soldered. So we need to check for any shorts around here. Yeah. Was that we got 2 diode junctions, and that's okay. I expect the same here, I guess. Diode junction, base collector, base emitter reads higher. That's okay, and this is probably the same. Ah, have we got a solder bridge in here? Let's see if we can zoom down any closer than that. I'm thinking between these 2 pins here, we might have a solder bridge. Try a bit of flux. Yeah. And just warm them up again. We've still got a short. I'll get a bit of a solder braid and then try and redo it. Yeah, no, it reads okay now. Yeah. There you go. I did not do that deliberately by any means, but it's a very good example of why you need to be sure that you check your work. Yeah. I'm still not too happy about these two. They look a bit close together to me. It reads okay. No, it reads okay, so it must be okay. Okay, that's that one done. Right, so we got the last heatsink. We need to get this one in place. Let's zoom out. Okay, so I've unsoldered this again. I'm pretty sure I checked this before, but let's just be double certain. So we can see this is a double diode. So we should see a diode junction here, a diode junction here. Yeah, nothing else. This one is it's also a double diode actually. Common cathode. That looks okay. They're all double diodes. Common cathode. The other way. Right. Let's have a look at this one. Yeah, double diode. Yeah. Double diode. Oh, they all check out okay. So look on the PCB where they just came from. So we have 2 double diodes here, common cathode. Now I've taken these out of circuit. I'll just move this so you can actually see it up. But Bit better, I think. Try that. That's a capacitor charging, that's fine. That's a capacitor charging, that's fine. I've no issue with that at all. Reverse the polarity, I should see the same. Capacitor charging, yeah. That I've got no issue with. Now, the two outer legs will be coming from the coil. So what I'm seeing is the resistance of the transformer. Yeah, the coil's here. So that's just the resistance of the secondary of this, yeah. I think that's what I was probably seeing. Let's check this one. This one reads quite low. This might read short because I'm reading again across the secondary here to here of the coil, yeah. But this one's reading about 3 ohms. And obviously in both directions. Well, very low resistance on this one. I need to probably have a look to see where that's going to. Because so far we've got no explanation of why the main transistors that drive the power supply primary blew up, yeah. Okay, end to end, again, I'm not surprised that's short. What's happened to the meter? It's just one of them days today, isn't it? Look to the meter then. 25 or more years, 27 years of owning this, it's never done that before. Yeah, so again, I'll be measuring across another secondary. There's another transformer down here by the looks of it as well, or an inductor. I'm not particularly surprised about that. But to the middle, that's also reading very low resistance. These are not looking right, are they? I can't understand. Why I'm reading those low resistances. I'm not on diode mode again. So I switched the meter off and back on again. That diode's okay. That diode's okay. These inductors, I'm guessing, are just feeding to these secondaries. Let's have a look on the output of all this, yeah? Let's have a look on the output of all this. So, black to ground, yeah. This must be 3.3 volts, I reckon. That is really reading low. I wonder if it's because I'm on diode range. That's reading even lower. Let's go on to resistance. Oops, losing that, weren't we? No, 46 ohms, that reads okay. That looks okay. 7 ohms, that is quite low, but on the 3.3, that's like half an amp. That is 7.1, yeah. Not 1.1, yeah, 7 point, okay. 7 point. Yellow. Quite high. This should read high, this is the green wire. And the purple one, which is 5 volts standby, should read high. Yeah. I'm going to put this in and try it, but what I'm going to do is I'm going to use the current limiter, yeah? That current limiter thing with a light bulb on to make sure. Okay, let's put it back together. least if you're using current limiter, when I say to make sure, it means that if something's wrong, the worst thing's going to happen is the light bulb's going to light up. Okay, let's put it back together. Okay, so that's soldered back in place. So what we'll do with this, we'll try it, yeah? I'm going to use the light bulb. Let me just zoom the camera out a little bit. So I've got everything together basically, enough to test this, yeah? So what we'll do is, we'll just balance this up on something that's definitely insulating, yeah? Just old folder will do, so this can just go loose. The power we need to plug in to the main board, yeah? So there's power coming in. I can just go there somewhere out the way. Put plastic on that, safety. We'll connect a hard drive. Let's find a SATA power connector. This hard drive doesn't actually work. I mean, it spins up, yeah, but it doesn't work. It's not a good drive. But we can use it just as a load. We need some sort of load on the power supply. See if it works, yeah. So that can go there. We'll keep all this for measuring voltages. Here's the fan. Fan connects this little PCB here that was effectively screwed to the top of this, yeah. So we can just, for now, just connect the fan so we've got some sort of indication if it powers up as well. So that's all ready to go. I'm expecting when I first turn this on, obviously it's not going to power up, but I should have 5 volt standby on here, yeah. If we've got 5 volt standby, we can connect the green to one of the blacks and start it up. Okay, so I'm connecting via the light bulb. Let me see if I can turn the camera out so you can actually see that, yeah. Let's come over here, yeah. So there we go. Switch this off. So up on top of it is a light bulb, yeah, and we're connecting via the light bulb, the limiter. So that's there. We can switch this off for a minute. We need a power lead, of course. Let's just get the soldering iron out of the way. We don't need that. Okay, so power lead is coming in. The main power's turned off at the moment. Power lead coming in. This switch is on here. There's an on-off switch. This is on, yeah. So I'm going to turn the power on over here. What's in your ways you can't see? No, you can't see. This is moved a little bit. There we go. I'm going to turn the power on over here, yeah. And when I turn this on, I'm going to see what this light bulb does. If I've got a short or some sort of load, that bulb's going to come on quite bright, yeah. Let's see what happens. Oh, that's good. It's on then dimmed, yeah. So that means this is drawing some power, but not a lot of power. Oh, didn't like that though, did it? Didn't like that so much. Just try to get. I wonder if that's because when I switched this on, it was. Let me leave that now. I want to let everything, like the capacitors to discharge basically. Yeah. Wasn't happy with that flickering, that's for sure. Let's also have a look to see where's the purple lead. Purple's there. This is 5 volt standby I'm checking for. There is some voltage on the standby. Can you see it? There is some voltage in there. So I'm just letting everything discharge, the capacitors. I'm going to try it again. I don't know if that flickering was to do with the PFC circuit, because effectively this was taking some power, so this has got a low voltage, but I don't think so. Because the light bulb was lit to some extent. Let's have a look at what it does. I've got 5 volt standby there, yeah? I've got 5 volt standby. I think this is going to be a matter of turn this on. Let's see what happens, yeah? Without the limiter. So basically, if your picture goes blank, yeah, that's I've just tripped all the power out in the workshop. Okay, so I'll just let it just kind of discharge, and I'm going to take this limiter out, yeah, and see what happens. See if it actually survives. I'll just pause this a moment while I just let the voltage discharge. Yeah. Yeah, I'm now going to switch this direct to mains. Yeah, and we'll all be sitting here in a few more seconds time, or all the power will trip out. Ah, see how I dived out the way there. Okay, we got 5 volt standby. That's good. Nothing's blown up. Nothing's gone bang. So what we're now going to do is try and start the power supply up. So I'll find a little bit of wire and we'll short the green to one of the blocks, yeah, and see if it actually powers up. Switched off for a second. I've taken this off. I need to get myself a bit of wire. One moment. Okay, so what I've done is I've just taken a bit of wire here, yeah? So I'm connecting from the green to the black. So that just grounds the green, so that will start this up, yeah. I put the voltmeter on the red wires, which I think is probably 5 volts, but it could be 3.3. So when we power this up now, the main power supply is going to start up. So because we've not got the current limiter in, because it doesn't like it, this is the next opportunity for it to all go bang, yeah. I won't dive out the way this time, but I might disappear. It's working, yeah. That's the reaction, yeah. Can you see the fan? Fan's running. 5 volts is good, yeah, we got 5 volts coming out of it. Let's just check the other ones. Orange, what's that, 3.3? Yeah, 3.4 is good enough. Red we've tried. Where's the yellows? Yellow should be what, 12 volts I'm guessing. Yeah, 12.26. So it's running. We need to load test it, but I think we can consider that a repair. Yeah, just need to put it back together now. But the ATX is working. These lower resistances on the outputs were obviously fine, and I'll see you all guys on the next video. See you now. Bye.